Hi, the purpose of this video is just to go over a few of these exponential and uh, story problems to kind of refresh it or to keep your mind going with what we were talking about before break so you don't lose it all, so that when we come back we're ready to jump into continuing where we left off. So the best way to use this video is I'm going to give a problem. Once I've kind of described the problem, pause it, try to solve it on your own, and then come back and play, and I'll talk through how I solved it and what the solution is. And if you're getting a little bit, maybe pause it and go back and see if you can do the rest of it. But kind of go back and forth. Don't just sit and watch the whole thing. Try to work it with me as we're going. So let's get started with the first problem. First problem I have here is a half-life problem. Piper has 500 grams of material, and it has a half-life of 3 weeks. And we're going to write an exponential model based on number of weeks. We're going to find out how much is left after 2 weeks, after 12 days, and how long it'll take to decay down to 100 grams. So pause the video, try to do this on your own, then we will come back, and when you're ready, unpause it, and I will keep going. So we know it has a half-life of 3 weeks. That means that my growth factor is going to be 1/2 because it's cutting in half. But this is an interval of 3 weeks. So we have to keep that in mind. Oh, my pen is going crazy. So I'm going to switch over to another board that gives me a little bit more room to work. And I don't want this one. So let's clear this. And we have 500 grams and a half-life of 3 weeks. So we could right off the bat write a function for this. We say f of n equals 500 times 1/2, I'll put 0.5, to the n power, where n equals number of 3-week periods. But that's not really helpful for us because who talks about 3-week periods? So we're going to switch this over to, and in part A we asked for, we wanted some function in terms of weeks. So we're going to say, well, we have our factor of 5. We want weeks here, but it takes 3 of them. We're taking this 3-week period, and we're taking 1/3 of it. This is our 1 week, so we're doing this weeks over 3. This would give us our function we could work at. If we don't want to work with that fraction in here, I'm going to say W equals number of weeks. We could also come along and say, let's go with this one. Take this to the 1/3 power. I don't like it that thick. 0.05 to the 1/3 power, or the third root of 0.5, is going to give us 0.7937. So this would be the growth factor for 1 week. So we could instead make this function a function 500 times 0.7937 to the weeks, and now I don't have that fraction involved there. Either one of these equations, either one of these functions would work to answer part A. So for part B, oh, my pen's upside down. For part B, we want to know after 2 weeks. That's pretty straightforward. We have our formula already, and I can use either one of these formulas. So I'm going to use G. 500 times 0.5 to the 2/3. We're doing 2/3 of the 3-week period, so that kind of makes sense with this function. Or we're plugging in 2 here for a number of weeks, and would work the same in either one of those functions. That's going to say after 2 weeks, we have 314.98 grams. For part C, we're going to 12 days. And we can, again, do that 2 ways. We have our function in weeks. I have 12 days, so 12 days would be 12 divided by 7 weeks. I can make that a fraction. Now, that's kind of clunky if I'm using this formula right here, because then I have a fraction divided by a fraction, and I probably don't want to do that. If I'm using this function, and I'm just plugging in W there, then I'm pretty well set. So I could go h of 12/7 would be my way to go on this one, is 500 times 0.7937 to the 12/7 power. Now, my other way to do that is I'm doing days instead of weeks, or I have a different period, so I could just say 3 weeks equals 21 days. So I could make myself a new function, and I could make this, let's go k of d, write this in terms of days. So we have 500 times my 0.5 raised to the days over 21. And that's going back to here, I'm breaking this up, this 3-week period, into 21 days. So number of days over 21. So I could come to, oops, I'm trying to go too fast. Not erase, undo. Pen, there we go, of 21 would be 500 times 0.5. I don't want 21. Yeah, I still mess up now and then. I want 12 days, so we'll go to 12. To the 12 out of 21. Either way, we're going to get 336.475. And 12 days is not quite 2 weeks, so I should have more after 12 days than I have after 2 weeks. So this is, again, making sense. Always look back at your problem and see if it makes sense. Last question was how long to get to 100 grams. And again, what was my function? My function was G of W. We'll use that one. G of W is 500 times 0.5 to the weeks over 3. Now, when I was giving you the time, I could plug that in for weeks or days. But here I'm giving you amount. That's what the answer to the function is. So I have 100. Here goes in for G of W. I don't know W. So I plug that in here. And now I'm ready to solve this equation. If I have a little room to write. So we'll start off by doing what's outside the function. So I divide by the 500, and I get 1/5, or 0.2, is 0.5 to the w over 3. Now I have this w over 3. I'm doing something here, but that's inside the function. I can't do that until I've undone the function. And I'm going to, I'm going to undo the function by going back to my old pal, b, b to the n equals, t, I forget what letters I was using, is the log base b of t equals n. That's switching between the exponential and the log form. So I could say here the log base 0.5 of 0.2 equals w over 3. And now I can divide both sides by 3. And I get 3 times the log 0.5, base 0.5 of 0.2 equals w. And that's going to give us about 6.97 weeks. So it would take about 7 weeks to get down to 100 grams. Yay, that's the first problem. Let's do this. Second problem, moldy growth. This is one where we're dealing with percent change. So again, Sapphire Hound, I should have fixed that, found a spot of mold on the wall, area of 3 square centimeters. She found that that mold would grow at 12% every day if left untreated. So we want how much mold will be there after 16 hours, after a week, and how long to get to 3 square meters. So give this one a try. Pause the video. Come back to me. Okay, so we have 12% every day. This is not the growth rate factor. This is the growth rate of 0.12. So my growth factor is going to be 1 plus the growth rate. It's 1.12. So my function here is going to be f of x. I won't use x. This is every day, so let's go f of d equals 3 times 1.12 to the d power. And that's the function we are going to be working with as we try to do this. So, in question A, we're asking how much is there after 16 hours? And 16 hours is going to be, there's 24 hours in the day, so it's going to be 16/24 of a day, or 2/3 of a day. So on problem A, we're just asking for f of 2/3, which is 3 times 1.12 to the 2/3 power, which is about 3.235 square centimeters. Part B, we want 1 week. 1 week is 7 days. So we just want f of 7. 3 times 1.12 to the 7th power. And that's going to give you 6.632 centimeters squared. Not much. It's about doubled in 1 week. Oh, wrong button. Go back to here. Go back to there. Let's go here. For C, we want to get 0.23 square meters. Now the first thing you have to remember is if this is 1 square meter, that's 100 centimeters by 100 centimeters. So this is going to be 10,000 square centimeters. So 1 square meter is not 100 square centimeters. 1 square meter is 10,000 square centimeters. And our function is working with square centimeters. So I have to use that number. And I will come along and say 10,000. Oh, but I want 3. So I need 30,000. Is 3 times 1.12 to the d power. So again, now I'm just solving the equation. So I solve what's outside. I divide by 3. And I get 1.12 to the d equals 10,000. Once again, I'm in exponential form, so I'll switch it over to log form, and I'm going to get the log base 1.12 of 10,000 equals d. And that's nice. It gives us right to the answer. So now, and just remember, the way I'm finding these, again, I'm using the change of base formula. That says the log base b of n is going to be the common log of n divided by the common log of b. If you're using your calculator, that's the way you can do that. This is going to give you d is 81 point, I can read my writing, 27. Or that's going to be about 11.6 weeks, or about 3 months. Again, this question was to refresh that idea of percent growth going from the, let's do this here. Going from the 12% every day, the growth rate of 12% to the growth factor of 1.2. We need to go back and forth between those. Be comfortable with that. One last problem to do. A pond of algae. January 15th, Diego looked at his pool. Estimated 1% was covered in algae. Checked on February 4th. Estimated about 2% of the surface was covered. And we're wanting the rate the algae is growing. How much is covered on March 1st. And when will be completely covered. So again, try to do this on your own. Pause the video. Do it on your own. Come back and I'll walk you through it. So we know we went from 1% to 2%. So here my growth factor is 2. I doubled. But my interval, how long did it take to double? I went from the 15th of January to February 4th. That's going to be over 20 days. So if I'm going at, so let's go switch over to my other paper. So if we are looking at, and if I could write that as a function, f of n would be 1 times 2, because we're doubling in days over 20, because it's taking 20 days to double. I want the growth rate. I need to find out how much per day. I need the growth factor per day. So that means I only want 1/20th. So I take the 2 to the 1/20th power. Or if you'd rather think of that as the 20th root of 2. And I will get 1.0353. And this is my growth factor. But again, remember the growth factor is 1 plus the growth rate. So if I subtract 1, I get 0.0353 is my growth rate, or my answer, well, yeah, my answer for A. I'm looking at the wrong problem on my other screen. We're growing at a rate of 3.53% per day. So that kind of gives us the idea there. On B, I need March 1st. So I need to know how many days. So March 1st. So if we went January 15th, we have 16 days to get to January 31st. February will count leap year. So we'll say 29 days. And then we're March 1st, so that's one more day. We add this together, we're going to get 46 days. So you could answer B without doing A, because we have this function here. I could say f of 46. Oh, I should have a D there, sorry. Is 2 to the 46 over 20. Or I could come along and say, oh, I have my growth factor of 1.0353 and take that to the 46 days. Either way, I'm going to get the same answer. I'm going to get 4.93. So 4.93% of the pond is covered. Now, one thing to quick maybe talk about. We're talking percents here, but the percents are my answers. We're saying this is 1%, this is 2%. Percent is kind of the unit on here. I don't have to be moving the decimal point back and forth because I'm just talking about 1%, 2%. It's not the same as when I'm talking about the percent growth, because that's percent of the area of the pond. I'd need that as a decimal if I had the full area of the pond and I wanted to find the actual area that was covered. I'm simplifying things, so I'm not messing with that. So, part C. When will the pool be completely covered? Completely covered is 100%. So I would go ahead and do 100 equals... again, I can bypass this question to do that. So I'm going to do this 2 to the d over 20. Oh. Because I don't really need the times 1. So I can go straight to log form. I can say the log base 2 of 100 equals d over 20. So then I can multiply both sides by 20. And I'm going to get d equals 20 log base 2 of 100, which is 132.7 days, or about 19 weeks. So that pretty much covers the big ideas of this unit, which was looking at, hey, from some information, can I find a growth factor? Can I find a growth rate? Can I write an exponential function? Can I change the interval of the function to make it more usable? Can I plug numbers in? Can I evaluate, work with it? Can I solve it? Can I use logarithms to solve that problem for other values? So we'll see you when we get back.